Okay, I want to talk about what I've done so far. I had the 3D model and I broke it up into pieces, one half and one half. And this is the first part I printed. And this is the one where the PLA was feeding into the tube and the tube was collapsing and it was making this clicking noise. It was trying to feed the PLA through the nozzle, but the tube was collapsing and it was just clicking. It was trying to push it and it wouldn't do it. So it basically aborted the operation, and I almost had this done. Another 4 or 5 hours and it would have been finished. So I fixed the problem with the tube. If you remember, I was going to take one of these. I was going to make a little extension on there. So I was going to take this part and I was going to cut it and screw it in there, put the extension on here, and then put the other piece on the top end so it would be further away from the heat source so the tube wasn't getting hot and collapsing. Got these little fingers in here that squeeze down on the tube, and that's why it was collapsing. It was getting hot and these fingers were digging into the tube and collapsing the tube. And I switched from a 4mm nozzle to a 6mm nozzle, and that I don't know if it makes a coarser print, but I was trying to get the print done. I wasn't too concerned about the quality because I knew this was basically a prototype part, and I wasn't really after the quality right now. I was just trying to get something done. So I tried printing it again with the coarser setting, and what was happening was that it was bowing. The part that sits on the plate, can you see that? It bows right here because this gets hot and it curls up. And it curled up here too. So I needed a wider area for this to hold that down. Now when I looked at this one I printed before, I didn't notice it, but it's curled up here too. It also curled right here. Now this part remained flat, but this inside piece was curling. So what I did was I went in there and I put these little tabs on here. There's a little thing you can do to put these little round circles wherever you need them. So I put these little tabs on here to give it more surface area to hold on to the plate. But then it started curling here too, right here. I don't know if you can see that, but there's a little curl right there, a little curl right here where it starts curling up. What happens is the nozzle goes across there and it hits it all the time. So that didn't work out too well. So they got this thing called raft. What it does is it builds up this plate that the print attaches to. And this is what happens. This is the raft, and the print builds up on top of this raft. And that seemed to be working really good. It gives it more surface area to contact, but it's still curling a little bit. But it's a lot better than what it was. Now what happened here was that I was moving the box, and the card is attached to the top of the box. And when I was moving the box, so that the PLA was, I have to turn the box so I could use the controls, but then I turn the box so that the PLA makes a straight line into the printer. And when I grabbed the box, I pulled the card. Now the program is in the card, and it drip feeds into the printer. So when you pull the card out, you lose the program. So it stopped, and I couldn't restart it. I tried to restart it, and it didn't know where it was, and I ended up digging into the part. So this part stopped too. Now this is about 3 hours worth of work right here. And what I did was I opened up I put lines here instead. There's different patterns you can put as the infill, and I put lines because it makes a weaker part, but it increases the print time. There's a lot of different settings in there, and I really, I'm kind of learning it as I go. But anyway, this raft idea was working pretty good. So I started it again. I started the part, and it got up to it's doing the raft, and then it stopped right here. And I thought, well, that's kind of strange. So I started it over. This is like an hour and a half right here to build this raft. So I started it over, and it did the same thing. It stopped again right there. So I figure it must be something in the program that when I accidentally pulled the card out, it disrupted the program. So I went in and I reloaded the program, and then it was telling me that the card was corrupt. So I guess when I pulled the card out, it didn't have a clean exit because it was running a program, so it messed up the card. So I had to get another card, reload the program, and on the print you have different options. You have like better, good, not so good, and draft. So I didn't want to go with the draft, so I went with the not so good because I wanted to just print it to see what it looked like, to kind of get an idea on what needed to be done to it, and if I missed anything, I didn't want to waste a lot of time printing it to find out I got to print it over again and over again and this and that. So I put it on not so good, and I was able to print a part. So I was using the raft. I printed the part, and it finished the part, but it's really came out really oh, how do you say it, poor quality, because I had it set to not so good, and it turned out not so good. But it gave me an idea of what the part looked like. But when I tried to take off these supports in here, I was battling this really bad. I was trying with pliers, this and that, and the quality of the holes was really bad, and the infill, the stuff here that supports this edge here, I couldn't get that out. Then this part was built upon a raft, and I tried getting the raft out, but what happens is that this piece here, which is the parent material, attached itself to the raft, and I couldn't separate the two. It actually melted right into it, and I didn't expect that. I expected it to peel apart. So, I mean, I tried, I even had to use the chisel to try to get it out, and it just wouldn't work. I couldn't get it to work. But I got the part. So what I thought about doing was have to grind this off, and I couldn't get that piece out, couldn't get this piece out. So I think basically I'm gonna have to scrap this part. So we got to come up with something a little different. The raft idea was working. There was no warping in the part. It worked good. So I gotta think about this, but that was working good, the raft. But it just sticks to this part, so I just gotta figure this out. And I got this, I got my stock that I bought. So I cut it into the different pieces, because this one piece here is going to be the one that goes on the motor, which makes it tip this way. That motor is going to be on the other side of this part. It's going to be back here somewhere. But then this one here is for the vertical motor. It's going to sit inside of here. Then the belt's going to come around here. It's going to go into the motor. That's what's going to make the table rotate. Now this one here, it's like an idler. It's going to go over here, and that's part of the one in the back where the motor's in the back, and I need to get the belt to the front. So there's a belt that goes around here, goes over here, goes to this pulley, this one, and that's what makes it go like that. Then this, like I said, this one goes on top. That's going to make the table rotate. But I was hoping this would work, but it didn't work. So I think I'm going to have to go with the regular setting, go with the good quality, and try it again, but I got to figure out how to solve this problem of it warping. But I got these cut. Got to bore a hole to attach it to the motor. Got to turn the diameters for the bearings. Well, it's not bearings, it's bushing. I got some brass stock, and that's going to be my bushing material because I don't want it riding into plastic. These holes here is where this tubing's going to go. I'm going to like epoxy it in there, and then these shafts are going to ride on that tubing, act as like a bearing material. This is brass, got it at Ace Hardware. It's a 3/8 OD with a 14 thousandths wall. And I got my vise come a little bit further on it. Got the slots in it. Slot up here. Gonna put a steel insert in here. And I made it out of aluminum to try to get it a little bit light. I don't really need a steel vise, but I need the steel jaws. And I got the cutters for my table, the T-slots for my table. So we're getting there. I got the little 45-degree cutter. Because I'm going to put a, you know how it clamps the end of the piece. So when I make this steel insert, I'm going to have a 45 on it, then a 45 on the other side, so whatever part I put in there, it'll grip it to keep it from flying out. And the thing about the steel insert is I can also make one with just straight jaws, so it doesn't have to have the 45 in it. That way I can just grip on a little piece of part if need be. And yeah, when the power went off, it flickered. So what I ended up doing was I got a battery backup. To install in the system, so I won't have that problem anymore with if the power flickers, it knocks out the unit. It's not that the unit will stop, but it remembers where the program ended, and it'll start again. But the issue is that when the power goes off, the heating elements go back to 0. So if this is on the plate and the heating element goes back to 0, then this piece will not adhere to the plate anymore, and it'll come off or come loose. So it's not an issue of the power going off and coming back on if you happen to be there and catch it. But you know, when you got these long runs and they're 18-hour, 20-hour, you can't be sitting there watching it all the time. So that's why I got the battery backup, so that if it goes off, it'll just stay on. because I don't want it going off and then losing the heating element and then the part not sticking anymore. And then when you resume it, the part comes loose. And that's how you take these parts off, is the bed is heated and these parts adhere to the bed, and that's what keeps us down. So when the bed isn't heated, this part, that's how you take these off, because you let the unit cool off and these parts will come off because of the difference in the temperature. So I got that battery back up.